Okay, so we're now up to directed graphs and networks. So this is going to be a bit harder. And again, you don't always have to understand everything. If you can understand bits and pieces, you're going to accumulate marks. But certainly if you're trying to chase an A or a B, this is important stuff. But it is certainly a bit harder than the undirected graphs. So if we go back to that previous slide again, just have a looking at what I just had. So directed graphs. So directed graphs, these graphs have arrows on the edges, on the roads, but we're not going to call them roads, we're going to call them edges, and they're indicating a direction to follow. So copy that down, and when you're ready, press play again. Okay, so critical path analysis. This is high level, so you just need to focus. So these are the organization of activities to minimize time and cost, because we're going to be doing more than one thing. You just have to work out which order to do things so you can either minimize time or minimize cost. Like for instance, there are some tasks that you do in real life that you can do at the same time. For instance, you can boil a jug of water and you can read a paper. You don't have to do one thing and then wait and then do the other. You can do some things at the same time. But there are other tasks that can't be done until you've done something before it. And something before it is called a preceding activity. So for instance, if you want to eat toast, you have to cook the toast first. You can't eat your toast until you've cooked the toast. So for instance, cooking is a preceding activity to eating. Okay, so I want you to copy that down, and when you're ready, press play again. Okay, so we're back again, and for instance, here's an example of 4 things that you might do in the morning. You cook your breakfast, which I'm calling activity A. You eat your breakfast, which is called activity B. You download emails, activity C, and you read emails, activity D. And the time that these things take are on the far side. So we've got 10 minutes to cook breakfast, 6 minutes to eat it, 1 minute to download emails, and 5 minutes to read emails. So if you did them one after the other, like for instance, if you cooked your breakfast and then you ate your breakfast and then you downloaded your emails and then you read your emails, you've got a total of 12, 22, come on, 22 minutes. So you have 22 minutes of activities, but it's not going to take you 22 minutes if you can order activities that some things can be done at the same time. So there's predecessor activities. So before you cook breakfast, you don't have to do anything, but before you eat the breakfast, you must have completed activity A. Downloading emails, you don't need to have done anything before it, but to read your emails, you must have downloaded them. So some activities have nothing before them, and some activities have activities before them. So what we're trying to do is try to construct what we call a network diagram. And at this stage, you haven't seen what a network diagram looks like. So if we flick to the next slide, this is what it looks like. So it looks like, for instance, if we had taken 22 minutes, like for instance, activity A, activity B, activity C, activity D, if you did them one after the other, you've got 22 minutes. But some of the activities, and that's not the way we're going to do it, some of these activities can happen at the same time. So for instance, you can be cooking your breakfast and downloading emails when you first get the activity started. So they can all start at the same time. And then from looking at the short one, from downloading your emails and reading your emails, so we're going along this journey to the finish line. The finish line being you've done everything. But with cooking breakfast, which takes 10 minutes, so the notation is the activity is the letter and a comma, and then the time, or could be the cost, is the second. So activity A is cooking breakfast and it's taking 10 minutes. Activity B is eating breakfast, which takes 6 minutes. Okay? And down the bottom, we've got downloading emails, which take 1 minute, and then reading emails takes 5, and then you get to the finish line. Now, please note that diagrams don't have to be drawn to scale, so you don't have to represent 10 minutes or 1 minute as different length lines. You just draw a line, and you don't make your diagram small. If you make your diagram small and have stuff all around it, you will lose information. Okay, so there's an assumption also that at some stage while you're eating breakfast, you're going to be able to read your emails. And sometime while you're cooking breakfast, you can be downloading your emails at the same time. These things can happen simultaneously, not one after the other. So copy that down, and when you're ready, press play again. So this is a little bit harder, and again, we're just trying to get the idea of drawing a network diagram. So the previous diagram, which had the four things happening, is a network diagram. So here's one where we've just added a couple of other ones. So we've got preparing breakfast, cooking breakfast, eating breakfast, so they're all connected. Having a shower, getting dressed, brushing teeth, they're a different set of activities, but some of them rely on some other activities happening before, and then we've got our emails happening again. So again, you won't have to work out what follows what. You'll be told, if you're asked to draw a network diagram, you'll be told what the activities are in terms of predecessor activities. Sorry about that. Predecessor activities and time. So you don't have to worry about which is which. You'll be told in the question. So, for instance, to prepare breakfast, you have to have nothing happens before. But to cook breakfast, you must have prepared breakfast. But to eat breakfast, you must have cooked it. But it's also saying, before you eat breakfast, that question's telling you that you've got to get dressed and also download your email. So the question's telling you the information. You don't have to think common sense, like obviously things can happen in different orders. Activity D is saying that you have to, before you have a shower, you've got to get breakfast ready. And before you get dressed, you have to have a shower. And before you brush your teeth, it's saying you better eat your breakfast, otherwise you're going to have to brush your teeth twice. And also it's asking you to, before you brush your teeth, you've got to read your emails. And for downloading emails, it's saying before you can download emails, you've got to have prepared breakfast, so you do something before that. And to read emails, you've got to have cooked breakfast, you have to have got dressed, and you have to have downloaded your emails. Now, don't get stressed about which follows which. The question tells you these are the things that are happening, and down the final column is the time taken. So I want you to copy that down, and we're going to look at a network diagram. So the question says construct one, but again, because you haven't had much practice in this, we're going to draw this one for you. So press pause, and when you're ready, go again. Okay, so we're back on again. So we move on to the next slide. So where we start is if there's nothing before it, which was A, that's where you start from. And with this one, so we've got nothing before it, which is A. So now we look at activities that have A before it. So we've got activity B is coming off A, activity D is coming off A, and activity G is coming off A. So we have to represent those three coming off A. So we've got activity B, D, and G all coming off activity A. Okay, so you can see how we've done that. And going back to the information. So, coming off, it doesn't matter where you start from now. So we've got activity. Let's look at activity B. So we've got C comes off B, and that's the only one. So if we go, and we also got H comes off B. So let's see how that diagram looks. So let's go back. Sorry. Yep. Okay, so we've done A. So A is on the diagram, so I'll change that to a highlighter pen. So A is done, and we've also got B is done, we've also got D is done, and we've also got G is done. So at this stage, it might be easier to look at some simple things, like for instance, so we've done D, B, G, and A. So there's our diagrams. So if you go back to the table, E is an easy activity because it only needs D to happen before it. So if we go to the chart, so there's E happening after D. And go back to the chart. So activity C, which needs B, and activity H, which needs B. If we look at that on the table. So here's activity B. So there's activity C and activity H coming off the end of B. And now we can tick those off. So activity C is done because C, E, and G are all done as well. And we've got H is done. F is done or H is done? H is done, Mr. Ko says. And we're just left with finishing off with activity F. And we tick that one off. So once you've ticked off all the activities, that's what the diagram could look like. These graphs are called directed graphs or directed networks because there's an implied direction from the start to the finish. Now, these questions, often as not, the diagram is given to you, and while I can't promise in the test what will happen, it's if we're asked to convert a table of activities to a graph, it'll be quite straightforward, but more likely than not, you'll be given the diagram in this sort of form, the network will be given to you, and then the analysis will happen. So copy that down. Again, have a look at the table, compare it to the graph on top of, one on top of the other, and you'll see how that one works. So when you're ready, press play again. Okay, so it's a little bit hard, but let's see if we can keep plowing through. So the next activity, this thing about forward scanning, it's a skill, it's a set of not exercises, but things to do that we can work out the minimum time needed to complete all the tasks in the shortest time. Because at the end of the day, we don't want things to take longer. We want things to take as short as possible. So this activity, this skill is called forward scanning. And once we know the minimum time, we can work out whether any activities can start their times later. So for instance, when we were downloading emails and cooking breakfast, we don't need to download emails and read emails at the same time as we were cooking breakfast. They could have waited a bit longer. So this activity is called forward scanning. And again, once you see an example, it makes more sense than just reading words. But at this stage, I want you to copy down those 2 paragraphs, and when you're ready, press play again. Okay, so the next word, what I like to look at is this thing called earliest start time, which we just use the acronym EST. So the earliest start time is the earliest time an activity can start after you've done all the prior activities that you need to do. And an activity can't start any earlier than the completion of a predecessing. What's Mr. Ko? What does he say? Predecessor. Preceding activity. So they call it predecessor, but preceding activity. So the earliest start time for the first activity, the earliest start time is the number 0. So when you're ready, can you copy down those things? And when you're ready, press play again. Okay, so we're looking at the question that we had right at the start, which was cooking breakfast and reading emails. So we have our diagram, and what we do is we add what looks like a little house. We have a triangle and a square, and what we're going to do is we're going to use those little bits of the diagram and put some numbers in. So in the triangle, what we do is we put the earliest start time. What I want you to do is just copy that down, and what we're going to do on the next slide is we're going to put the earliest start time for each of the activities in the boxes. So at this stage, I just want you to copy this down. Please, I'm telling you now, don't make your diagram too small. Don't make your little box and triangle too small, because you actually have to put numbers, and you need to be able to fit 2-digit numbers in the boxes. So make your boxes and your triangles big enough to fit 2-digit numbers. Otherwise, you are going to lose information. So copy that down. And we're back on live. So looking at the start, activity A and activity C, the earliest, okay, so we start with 0 time. We start with 0 minutes, and the earliest activity A takes 10 minutes, so we put a 10. So we just read along the line. So from the start, activity A takes 10 minutes, so we put a 10 in the box, and activity C takes 1 minute, so we put a 1 in the box. Okay, and then from the top, activity B takes 6 minutes, and these things should have arrows on them. So activity B takes 6 minutes, so this box, this triangle here could have a 16, and across the bottom we take the 1 and we add the 5 and we get 6. So in that top triangle here, we could put either 6 or 16, but you must take the largest number. If you put 6, then you can't have finished your breakfast. If you put 16, you have got the breakfast done and you've also got your emails done. So you always put the largest number, but it could have been 6 or 16, but you always put the larger number. So when you've done that, can you just copy that down, please? So looking at the next slide, so the minimum completion time is 16 minutes, and thus the other activities, which were the email activities, could be delayed by up to 10 minutes because these activities this way took 6 minutes. We're allowing 16 minutes to eat the breakfast, so that means that the emails could be delayed by up to 10 minutes and you'll still finish all your activities in time. And compare that, Mr. Coe just reminded me, if you compare that, if you did the 10 minutes, the 16, the 6 minutes, the 1 and the 5, which would add up to 22 minutes, but now we've got everything done in 16 minutes. And some activities can be delayed. Okay, so when you're ready, copy that down, copy all the information down, and when you're ready, press play again. Okay, so let's have a look at the activity that we had really a little while ago, which was brushing teeth, getting dressed, all these sort of things. Now what I've done is that information at the top, this information at the top is how we drew it. So what I've done is I've redrawn it just a little bit differently. So I've got D, again I should have arrows, so D and E I've just done a little bit differently. B has a line, so I'm just adding the direction. Okay, and what I've done is I've added the box and the triangle, and that's all I've done. So I've changed the top diagram to include boxes and triangles. So what I want you to do is I want you to copy that down, make your diagram nice and big because you need to fit numbers in the boxes and the triangles. We're not using the boxes at the moment, we're just using the triangles, but can you copy that down? And when you're ready, press play again. So what we've done is we're going to start by filling in numbers. So at the start, right back here, we put 0. So the activity started at 0, and at the end of A's activity, we've got a 4 in the top box. And now we're going in different directions. So again, the arrow should be here. So from A, D takes 4 minutes, but we've already got 4 minutes already. So 4 plus 4 equals 8. So 8 is the time there. Now before we go down to this spot here, we have to look at all the ways. So this junction here only has one box and one triangle, and we need to look at all the different ways. So for instance, if we go back here, if we go along B, we've got 4 plus 2 is 6. But if we go along the bottom, we've got 4 plus 1 is 5. But going across the top, we've got 8 plus 4 is 12. So we've got 3 options. We've got 5, 6 or 12, but you always have to choose the larger number. So 12 is going to go in that box there because the other numbers won't allow you to have finished the D and E activities. Okay, so just copy those down so far, and when you're ready, press play again and we'll finish off the diagram. So we're back on, and so now we've gone along and now we're at this next junction. So at this junction here, we're at 12 minutes. So we've got 2 options. We've got a 2-minute activity or a 6-minute activity. So 12 plus 2 is 14, or 12 plus 6 is 18. So which number are we going to choose? We have to choose the larger. And then once we've got 18, we've only got one more activity to go. 18 plus 2 is 20. The reason I had 16 there is because if you had gone 12 plus 2 is 14, 14 plus 2 is 16, that would be that number. But because we didn't have the lower number, that one's discounted, 14 is discounted, so 20 is the time at the end. Are we on pause? So now we've got a pathway from the start to the finish, which will end up taking 20 minutes. So if we go across the bottom, so we go across the bottom, then up, across, or up and down, across and across, we have a minimum completion time of 20 minutes. And what we do is we call this the critical path. And so the critical path is A, D, E, C, F. If you stay on that path, that's the minimum completion time of 20 minutes. The other activities that aren't on the critical path, these other activities G and H, they're going to happen, but they're not going to happen. They're not compulsory to happen at the same time. They'll be happening in the background. So can you copy that down? Copy that down, and when you're ready, press play again. Okay, so we're back on again. I use the word so apologies. So now we look at this thing called a float time. So the float time is the difference in time between those activities that are on the critical path and those activities not on the critical path. So this word float is like time that the activity can be delayed. Again, it looks complicated, but we're going to start using the other parts of the diagram, the boxes, to help us with the float time. So the latest start time. So the latest start time for these activities that aren't on a critical path is the latest time they can start and not delay the project. So this thing, latest start time, when we use the diagram properly, we'll see these times come into it. So at the moment, you just have to understand that a float time is the difference in time between activities on the critical path and those activities not on the critical path. So copy down those two paragraphs, and when you're ready, press play again. Okay, so we've got activities on the critical path A, D, E, C, F. So these activities cannot be delayed. They have no float time. They are on the critical path. But activity, for instance, activity G and activity H are not on the critical path, so they do have a float time. Okay, also I forgot, I've got activity B. So I've got B, G, and H, which are activities that aren't on the critical path. So if you have a look at the time at B, so looking at AB, which is 4 minutes plus 2 minutes is 6 minutes. So A plus B is 6 minutes. But at the end of B, I've got 12 minutes of time, so 12 minutes of time. So the difference between those two numbers is 6 minutes. So B could wait up to 6 minutes. To get to G, I've got A plus G is 5 minutes, and at the junction at the end of G is 12 minutes. ADE is 12 minutes, so ADE is 12 minutes. So if it's 5 minutes and 12 minutes, I could delay G by 7 minutes. And to get to activity H, which is going to be 18 minutes, from 12 minutes plus 2 minutes is 14 minutes. I've got 18 minutes from the diagram, which means that H could be delayed by 4 minutes. Now at the moment, this is sort of using common sense, but what we're going to do in future lessons is we're going to use the numbers in the boxes to help us find what these things are called the float times. But at this stage, this part of the activity is just using common sense. And if you look at the next slide, which is the exercise, if you look at exercise 17A on page 50, so on Moodle, you've now got to change to a different file. So you're looking at the file called Directed Graphs and Networks. It'll be there, and the answers are at the bottom as well. So have fun.